Welcome back to our series Neural Networks for Architects, Day 2, the mathematical thinking towards neural networks. Chapter 11, the Markov chain and probabilities. So we are towards the end of this day. I want to make a clear distinction to what we learned in the last chapter about stochastics, which is a gravitational thing. So gravitational people, we discussed that, a kind of hearing the alien's voice. The aliens is with the exponential, and hearing and working in sync, or producing in sync with the ideal, which is the alien's voice. This, I would say, is can be stochastics can be seen like that. So this is about understanding the alien's voice, stochastics. And in contrast to all literature, because there's no other word, I would make probabilities an alien thing. So this is what aliens do if they take a picture of a world, of our world. And this is about probabilities. So that's an alien thing. So now we want to go in detail looking at this. Let's see. So we had this kind of discussion I had in the introduction. So again, we are with these simple series of events. But the aliens don't look at the parts as these events as parts, but they look at sequences of that. They look at the connectivity of that. So that's the difference. It's the only difference if you follow this mathematical metaphor of what I'm talking about with the gravity and the light and so on. So it's a simple mathematical metaphor for that. So let's take this kind of series. 1, 2, this is what the aliens picture of the world. So they don't have any clue, as we've seen with our classification, prediction, and so on. They simply don't care. So it has no meaning. So, but it's still with numbers. So then we, here we get the different states. So there are only 1s, 2s, and 3s. So there are 3 different classes. This is what aliens can do without understanding anything. And then they're looking, and this is new, about they're looking for transitions. So that's the only thing. They're looking for transitions. So there, it's a transition from 1 to 2, from 2 to 1, from 1 to 1, and so on. So, and now they say, yeah, what are the follow-ups of a certain state? What are the following states of a set? So then 1 is followed by 2, it's followed, then it's followed by 1, it's by 2, and so on. So having this. So, and then we say how probable it is that a 1 is followed by a 1 is followed by a 2 is followed by a 3. How probably it is that a 2 is followed by 1, by 2, and by 3. A 3 is followed by 1, by 2, and by 3. That's it. This is introduced by Markov in 1913, and this is a principle of astonishing of all AI, of all internet we have today. That's 1913. All the important things developing in thinking, not in technical implementation, in thinking had been done in these times, beginning 20th century. So now we look at this and we have these interesting matrices always, the same like this. Very probable that 2 is following a 1. There's no no way that the 3 is following a 1 and so on. Just this as a color, in colors, or as a graph. So 1 is followed by 2 and with a little probability followed by 1. There's no connection from 1 to 3. So this is most popular in showing it on social networks and so on. That's the Markov process. So in this now, like we had it with the with the system and the standard distribution and the production according to a systemicity, the ideal of then the production there. Now we can run new series by random, which have the same probabilities in the way you go from state 1 to 3 to 3 to 1 and so on, to change states. So therefore, and that's the thing the aliens do. Very simple, that's it. So again, a lot to meditate. What is really going on there? But this is in sync with what the logarithm does, and this I would say is probabilities. So you're looking on the transitions, at the connections of things, and not at the things themselves, which is stochastics. So, and this is just the difference between gravitational and alien. Very interesting. So if you go here in architecture or design, again, this is with statistics. So you play with the sequence of things in a positive way. So it's a mechanical space. This is Jugendstil. This try to grow. This is a map of craftsmanship. This is a mimic of things. So it's growing, the same with Tonnet, for example. It's just mimicking the growth. This is Jugendstil, as we had it with the drawings and the tapestry. So, and if you go with probability at this, here are the things you don't have a global understanding. So you're not embedded in the principal flow of time. So you're not making a map of it. You're not following these lines of movements. You're simply out of space. And this, I think, is what, so you create your own perspectives to the world. And by that you can play. First this is a chair without legs. You have these different kind of materiality, and yeah, these things talk. This is a kind of irritated perspective to the world. And this, I think, is quantum space. And this is about Bauhaus in the 1920s. Complicated to discuss these things, but these are indicators how to look at 20th century. With lines, I would go like this. So this, for example, is a polyline in Euclidean and Cartesian space. You have these points, you make these graphics. If you go stochastics, so this is the French way, then you try to get the principal growth of things, so that all things are connected with a single line. And you're doing this with this power series. And this is done with this fit function here. And then you get this line. And you see they fit pretty well here, and they get with extreme values. This is a problem of all systems, that with their bounds, we discussed this. And these polynorms, they are quite good in the focus and they are center, they are safe there, because but towards the extreme values they get a kind of crazy. So this is not what in principle we would expect. But this is analytics. This is gravitational. So you have a global understanding of the ideal that everything should be the same and playing individual roles in this. So therefore this whole line is of a global same. And if you change these things, for example here, if you go here for 3, we have it. Then here we go. All the lines are the whole thing is adapting. So quite different from what we have here in statistics. Statistics simply caches out, as we said, and this simply means say, okay, if we have these points, then there are more of them. So you don't think in the ideal of this line, of the infinity of this line. You simply say, yeah, now we have 50 points. That's statistics, as in a metaphorical way. So what we have with probabilities is this, and we know it from Splines. So probability is just doing this game here, but not on a global scale. It's making a polynomial here, it's making a polynomial here, it's making a polynomial here, and it's making a polynomial here. So it has local globalities. And then it's morphing across these, localities. And by that it's adapting in a seamless way. And this is how aliens picture the world. So these are I think it's 3 different or 4 different perspectives the aliens take, and then they talk a new line, which is the spline. We know that as spline. That's probability line. It's a quantum line, I would say. So if we have that, so we can say classes, for example, classification, ontologies, and so on. They are not adequate. They are playing the gravitational game, and they are playing here. This is it's a classification. It's here. That's a classification. If you go here, you can't talk about classes. You should take the ontologies. You should talk about categories. They play in space. Classes, ontologies play in time. This is in time. They play in space. It's complicated to get, but I think with diagrams, with forms, with figures, with gestalts and so on, there's a kind of implicit mix-up of all these things. If you have a line, it depends on how this is done, whether it's a geometry, whether it's an ideal, or whether it's real, or whatever it's geometry or topology, or these things have to be distinct. It's not a kind of physical there because you such see the line. It's always a rendering, crisscross, and getting a little. You have to get an eye. So for that, I would say you can't see space. You can talk about it, and you can cut space, and then you have, like aliens, you cut space with one eye, you cut space with the other eye, and then it's intellectual to make a picture out of it. This is what aliens do, and this is what the space is about. Good. The same with evolution and style. So very important conceptions we have. For example, you see this disaster of 20th century. If you want to follow a certain logic and development in time, everything gets messed up. So like here with Charles Jenks, the evolutionary tree, and the book is a language of postmodern architecture in 2002. So all this is gravitational. Ontologies, classification styles, evolution, language, stochastics, predictions, all this is gravitational. It's like this in statistics and this in stochastics. So if we are going like this, the smooth line, yeah, then we should work like Markov. So simply see for the transitions, get probabilities in transitions, and by that you can have a picture of the world to talk about. And you're not afraid that you don't have to cover it. There's not a lot of work. You're sitting just there and you don't touch things. That's the beauty of it. And you see we have a self-understanding of an architect, of what a theory is and so on. It's to the very substance of our self-understanding, what we're discussing here and what is at stake with AI. So, but very important to see this simple example, complicated to get, with Markov 1913 is what Google and Co are doing. They're not doing different. From a mathematical perspective, this is how neural networks work. They can't do different. There is just this. So, and the rest is technical tricks to make it running. That's the principal mathematics. And of course, it's a little simplified access to it, but I think with this you get the turn. And don't say that stochastics is statistics and that statistics is probability. Take these three terms properly apart to talk about phenomena we are interested in. Back in time, gravitational; forward in time, gravitational constitution of space, out of time. Good. Thank you for watching. We will have, the last one will be on information and communication to make these conceptions clearer. But then we are done with this day. Thank you for watching and see you soon.